Hello everyone. So today I will be talking about the pouring time calculation. So last class, as we have discussed about different types of gates, isn't it? One was top gate, bottom gate, parting gate, and a step gate. And we have already discussed that in case of top gate, the time for filling the mold is minimum, isn't it? And in case of bottom gate, it was maximum, and parting gate it was in between top and bottom. Okay, so today what I am going to do is I am going to calculate the pouring time. Clear? So what is pouring time? So let us talk about that. So basically, if we want to define pouring time, so it is a time required to fill the mold cavity, that is known as pouring time. So time required to fill the mold. Okay, so if this is the mold, let's suppose this is a pouring basin, and here is the sprue, and this is runner, and through this runner this gate is there, and through gate we enter into mold cavity. This is the mold cavity, and at the top of this mold cavity we have riser also. We can just write it riser. Here we have a sprue, runner, and this opening is known as gate. Okay, so generally this riser is up to the level of a sprue. Whatever the height of a sprue is there, till that the riser is extended. Okay, so when you are filling molten metal inside, okay, here, then after once the mold cavity is filled, after that the metal will be filling this part, isn't it? Okay, so this will be filled, and also at the same time this will be filled. So when this and this completely it is filled, then we can say that mold is completely filled. So the time required to fill the mold cavity along with a sprue, riser, pouring basin, everything, it should be completely filled, no space should be empty. Then we that total time is known as pouring time. But here we will be calculating the time required to fill this cavity. Clear? Okay, so and these also can be calculated, there is no problem in it. We will do that. First we will calculate the time required to fill the cavity. Okay, so can you tell me how can you calculate the pouring time? If we just write pouring time, so how will you define pouring time? So to fill this cavity, what should be the formula? Okay, what formula we will use? So see, this is the volume, we have to fill this volume. Okay, volume of cavity divided by, see, what is the rate of flow of molten metal entering inside the cavity. So if flow rate is known, that means how much volume of metal is entering every second inside this cavity. If we know that, then we can calculate the time required to fill this volume, isn't it? So this is actually, and that term is known as flow rate. So we can say flow rate of molten metal. Now how we will just a volume of cavity we can denote it by capital V. And what about the flow rate? What is flow rate? So flow rate is actually it's the area of cross section into the velocity of liquid, isn't it? Let's suppose there is a pipe, okay, and in the pipe there is a liquid flowing, so we have to calculate the flow rate of this pipe. This is similar to pipe but not round one, but we can say that it is a pipe. Okay, so how do we define the flow rate? So let's suppose the liquid, in 1 second this much volume of liquid is like this line. In 1 second it reaches from here to here. Okay, so that means this much volume has come out from this pipe, isn't it? So what is this distance actually? This is the distance covered by this point in 1 second. That is the velocity, isn't it? From here to here it has come in 1 second, this point. That means this much volume has been, like, it has come out from this pipe in 1 second. So that is the flow rate actually, meter cube per second. So velocity is this distance this distance into, if we multiply with this area, then we calculate the volume of this zone. So that is the flow rate. So actually we can write velocity, just a small v, into area of cross section. Okay, and here the area of gate we will use, so AG. Okay, and this is the V max. Okay, the velocity, maximum velocity at this point. Okay, so this is the formula for pouring time. Okay, now let us see that how much is the velocity at this point. So we know about the top gating system. So let us take the case of top gate. In case of top gate, so how the top gate is shown? So here we have this is the, let us suppose this is the sprue, and we have the cavity. Okay, this is to be filled. Okay, and this is the gate through which the molten metal is falling. So see here, what is the height? Okay, we have to make one pouring basin also. Okay, so here already we have shown that this is HP, pouring height of the pouring basin, and this is HS, height of a sprue, and the total height is HT. Okay, and this is the point 1, this is point 2, and this is point 3. Okay, so we have to calculate the velocity at point 3, and the molten metal is filled up to point 1. Okay, this is all molten metal. So can we calculate the velocity at point 3? So we have to use Bernoulli's equation. So applying Bernoulli's equation, at points 1 and 3. So can you write the Bernoulli's equation? That is P1 divided by rho g plus V1 square divided by 2g plus Z1 is equal to P3 divided by rho g V3 square by 2g and Z3. Okay, Z3, if we take Z3 3 point as datum, then this will be 0. So point 3 is datum. Okay, at point 1, what is the velocity? 0. At point 1, what is the pressure? 0. This is gauge pressure, isn't it? P1 and P3 are gauge pressure. At P3 also this is atmosphere, isn't it? So the pressure will be 0. So can we say what is V3? Root under 2g. Oh, what is Z1? Z1 is this height from datum to point 1. What is this height? It's shown ht, so we will write ht. So z1 is actually ht. Okay, so we have got v3, that is the velocity here. So can we write pouring time? So t means pouring time in case of top gate. So we will write v upon ag into root under 2g ht. So this is the pouring time in case of top gating system. So let us calculate the pouring time in case of bottom gate system. So I'll delete it. So let me just take the snapshot of it. Okay. So I'm removing. Okay, next we are talking about bottom gate. So in case of bottom gate, just draw the bottom gate. This is the sprue, and we have a runner here, and here is the cavity. This is the bottom gate. So here is a sprue. If we just show the pouring basin and all, this is the point 1, 2 and point 3, and let's just suppose at any instant this one is filled up to point 4. We don't know where is that, just any instant we are taking it. Okay, so 1, 2 and 3. Okay, we know the heights. These are ht, actually complete height, and we can say this as at an instant height h, and this is the complete height of mold hm. Okay, so now apply the Bernoulli's equation between 1 and 3. Applying Bernoulli's equation between 1 and 3, that is p1 by rho g plus v1 square by 2g plus z1 is equal to p3 by rho g v3 square by 2g plus z3. We have taken z3 as datum 0, v1 p1 pressure, gauge pressure, that is atmospheric pressure is p atm, so gauge pressure will be 0, v1 0, p3 will never be 0. Here p3 cannot be 0 because here there is no atmosphere. What about z1? Z1 is actually ht, so but p3 we don't know. So let us calculate p3. So this is point equation 1. Okay, so next we will apply Bernoulli's equation between points 3 and 4. So 4 is atmospheric, so just write all the equations. p3 by rho g, v3 square by 2g and z3 is equal to p4 by rho g, v4 square by 2g and z4. What is velocity at this one? 4. Let us consider it as 0, because the if this is the opening through which molten metal is coming at some velocity, so this is considered that the mold cavity, its area is very big, so the height difference, like you can say the change in the height is negligible. That is, velocity of molten metal at this point is 0, because it's going very slowly, it's filling very slowly, so that's why it is considered 0. v3 we don't know, p3 we don't know, p4 is atmospheric, so 0. Okay, and z4 is h. Okay, z3, yeah, here you see v3 will be 0. Why? Because as soon as it enters inside the mold cavity, we are talking about the see the point, either you take v3 here here or here, pressure will be same because they are on same height, isn't it? This is the datum. But velocity at point 3 will be 0. We are considering inside the mold. So velocity at point 3 will be, because at point 4 it is 0. So all the, not 0, actually it's nearby 0. So all the points inside the mold cavity will have similar type of velocity. So we can say that V3 is also 0. So from here we come to know that P3, okay, Z3 is datum point, okay, this is datum 0. So P3 is equal to rho g h. Can we put it here? This is equation 2. So from equation 1 and 2 we get what? This is ht. What is z1? Z1 is this height, that is ht, and P3 is rho gh by rho g, that is h, plus V3 square by 2g. From here can we say that V3 is equal to ht minus h into 2g, ht minus h into 2g, and this is root under of it. So we have got V3, that is velocity at this point. Earlier we got the velocity in the top getting system, we were getting the velocity at 2g ht, but this time we are getting 2g ht minus h. So can we say that pouring time, that is T in case of bottom, pouring time in case of bottom gate system is equal to V divided by this area, that is area of gate, this is the area of gate, into 2g ht minus h. This is bottom gating system. Okay, so now we want to compare the bottom gate and top gate. Okay, so what will happen? So okay, let us move towards calculating the okay, 1 minute. This we have got the velocity. Oh, sorry, actually this is a velocity at one instant. You see here, this h is going to vary, so h is always varying, it's not constant. So how can we say that this is the pouring time? So this is wrong. So this is the velocity at an instant, okay, because h is varying. So let us let us consider that considering considering at an instant, any time at an instant, the change in height of metal inside mold cavity is dh in the interval dt. For a small time interval dt, we have observed that the change in the height is dh. Actually this is very negligible, as we have already considered that velocity with which this is rising is 0. So dh is much it's very small. Okay, so can we write if we can calculate the, if we can equate the volume which is increased. So when it is increased here, so if this is the this is having the area am, and if we calculate with dh, then this is the increase in volume inside the mold cavity. Are you getting? Where am is cross sectional area of the mold. Now at this point in dt time, how much molten metal has entered, that is equal to this one. Okay, so in dt time, so obviously velocity at v3 at 3 point, that is v3 into dt, that is the length into area, so area is ag. Okay, so v3 we know this value, so we can write am, where am is, just write it, cross sectional area of mold of cavity, mold cavity. Clear? And ag we know already, v3 we know. Okay, so what I'm going to do, I'm putting this value of v3 here, so it will be root under 2g ht minus h into dt. Now what I am going to do, this h term we will put it here, so dh upon root under 2g ht minus h is equal to ag upon am into dt. Now we need to integrate it. Okay, so how we will integrate, so at time t is equal to 0, t is equal to 0, h is 0, and at time t is equal to t bottom, that is complete pouring time, that is h is equal to how much, it will reach to hm. So these are the boundary conditions, so we will integrate it between 0 to tb. So where to do that? Okay, I'll delete this. Okay, so let me first take the screenshot. Okay, I'll remove this part. See here, so what I'm going to do, I'm going to integrate dh divided by root under 2g ht minus h is equal to ag by am into dt, that is from 0 to, actually at time t is equal to 0, height is 0, at time t is equal to tb, height is hm. So 1 by 2 root under 2g we have to take out. What will be the integration of that will be remaining hm dh upon root under ht minus h is equal to, let's take it out, and this is basically if we integrate it. Okay, leave it. Okay, see here, what is the integration of this one, do we know? See, just take this value ht minus h as u, so minus dh is equal to minus u, sorry, du is equal to minus dh, so dh is equal to minus du, so just replace it. I'll just do the rough integration, this will be minus du divided by root under u. So what is the integration of du divided by root under u, just integrate it, it will be u to the power 1 by 2 minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1, so and this is minus already, so here it will be minus u to the power 1 by 2 divided by, this is 1 by 2, so that is minus 2 into root under u. Check the integration. Okay, so this will be the integration of this, so just where u is equal to ht minus h, so I'll write directly, this is minus 2 into root under ht minus h from 0 to hm, let's remove this, is equal to ag by am, this is tb minus 0. Clear? Okay, so now put the values here, and we have got the formula here, we are going to get TV formula. This is TV, so we are going to get TV is equal to, this will go this side, so we will get AM by AG 1 by root under 2G AM by AG into, this is minus, so what 2 we have to take out, so we have to take out 2 into, if we put okay minus, so first we will put this, so 0, so root under HT minus root under HT minus HM. So this is the formula of time required for filling the mold cavity. Okay, so just write it fresh. TB is equal to 1 by root under 2G AM by AG. Okay, and what about this? Okay, 2 into root under HT minus root under HT minus HM. Finished. So this is the expression for time required for filling the mold in case of bottom gate system. So we have got these values. Now can we calculate the values? Okay, can we compare the value of bottom gate and top gate? In what was the expression for TT? It was complete volume of mold divided by AG into velocity V3, that was 2GHT. So it's a very simple expression. And look at this one, so this is the for bottom. So how do we compare it? So just let's see if it is possible to compare. What I'm going to do is, I'm going to make the mold cavity up to the height equal to HT. That means that the mold cavity, look at this. This is the sprue, this is runner, and here we have mold cavity. Its height is same, so this is HT and here HM is equal to HT. Okay, if take this condition, then can we calculate TB? In this case, if HM is equal to HT, then what is the TB? It is root under 2Z AM divided by AZ. What is this? This will become 0. So into 2 root under HT, only it will be remaining. Look at this. So what I'm going to do, we want volume here, isn't it? What is the volume expression? V is equal to area of mold into height of mold. So what is height of mold? That is HT. So we want HT here on the top, but here we have root HT. So what I'm going to do, I will be putting down 1 HT. So we are getting above 2 is there, so 2 into V divided by root under 2G, and here root HT will increase, so include this, and AG is there. Okay, we got the expression, simple expression for TB in case when HM is equal to HT. So you see that almost the time required for in case of bottom gate system is equal to 2 times of this top gate time required in case of top gating system. Okay, so it's almost 2 times. So in this case, in this particular case itself, this TB is equal to 2 times of T. Not always, it's in this particular case. Okay, so let us see the parting gate system. What will be the time required in case of parting gate? So let me take the screenshot of it. Okay, after that we'll see the parting gate system. So remove it and let's go for parting gate system. So in case of parting gate, what will happen? Let's draw the diagram. So here we have pouring basin. This is the sprue, and here we have runner, and this is parting gating system. There is this is the height h1 and this is height h2. Clear? Now let us talk about this. So can we calculate the time required to fill this part? This is Tp is equal to T1 plus T2. Time Tp, I am using P for parting gate. So T1 is how much? The volume V1. Okay, this is V1 and this is V2. Volume. So V1 divided by area of gate into velocity at this point, that is 2GHT. Okay. Plus what is T2? T2 is volume. Oh no, there is another term. That expression, you just go through that expression. The expression is 1 by root under 2g am divided by ag and root under 2 into root under ht divided by 2 into ht minus root under hm minus ht, sorry, ht minus hm. ht minus hm, this is the expression, and divided by something else, forgot. What's the expression? Do you remember? Oh, that's enough. Okay, so this is what, so where ht is okay. What about hm? Hm is h2. So remove this and write h2. This is h2. Okay, and v2 is equal to am into h2. So from here we will calculate am and put it here. So if v2 is given, then we can calculate am. Otherwise am may be given, so directly you can put it here. ag is common everywhere, ht is obviously given, and we will be provided h2 and h1. Okay, so h1, if v1 we calculate, this is am into h1. Okay, so this is parting gate. So let us solve one problem and we will see that how this works. Okay, this is one problem. Two gating designs for a mold. Oh, sorry, this is a mistake here. Mold. Of 50 centimeter into 25 centimeter into 50 centimeter are shown below. The cross sectional area of gate given AG. This is the AG value given, and this is the V, capital V is equal to 50 into 25 into 15 centimeter cube given. So we have to determine the filling time for both the design. Now both the design, which kind of design it is. So you see here, this is top gate, and you see here this is bottom gate. So we have to calculate the time required in top gate and bottom gate. So can we calculate it? So let us try. We have been given V and we have been given AG. So easily we can say in the first case top gets TP, TT, that is equal to volume divided by volume divided by Ag into root under 2G HT. What is HT here? It's given, this is 12 for HS, means a sprue height, but 15 is HT. So we will write here HT is equal to, where HT is equal to 15 centimeter. Ag is given 5 centimeter square. V you have to put this much and calculate this. So do it by yourself. In B case, what is TB is equal to 1 upon root 2G AM by AG root into 2 into root under HT minus root under HT minus HM, height of the this one. So how much is that? Root under 2G AM. What is the value of AM? This is the AM, that means this is 25 and this is 50. So it's 25 into 50 area divided by 5 into 2 root under HT is given 15 minus root under 15 minus what is HM? Oh, height is same. We haven't seen that. Okay, so actually if height is same, then it becomes much easier. What we need not to calculate this, we need not to use this formula at all. Actually we can directly go TV is equal to 2 into TT. So if we have calculated TT, then 2 times of this is TV. So it's much easier now. If okay, so we need not to use this equation. If the question is like this, please try at home this one, that parting gate system, like this same question, and you check that how much time it comes, like check the TT, TB and TP also, parting gate system, where H1 is equal to H2 is equal to 7.5 centimeter. So take this case that the gate is in between, just in the middle of the height of this cavity. So try this question and compare all these three values. We will discuss in the next class. So in the quiz I am giving this question, all the three values you have to find out, and then we will discuss in the next class. Thank you very much.